The second way of finding the moles is by using a formula. And what is the formula to find the moles? We'll discuss the first formula, that is yes, you can use these letters. It's not necessary you write the full formula. You can use these letters to write the formula. The first formula to find the moles, moles equal mass in gram divided by the molar mass. So how to use this formula? Example, if I say find moles of carbon in 36 grams of carbon. This is the first formula, and what is this? The number of moles equal mass in gram divided by molar mass. So the question is find moles of carbon. So we have to find moles of the carbon in 36 gram of carbon. So if we have 36 gram, how many moles are there in 36 gram of carbon? That's a question. So you have the formula moles equal mass in gram divided by molar mass. What is the meaning of molar mass? Molar mass is the atomic mass or molecular mass. If substance is an atom, it will be atomic mass. If substance is a molecule, then it will be a molecular mass. So we have to find moles in 36 gram of carbon. The formula moles equal mass in gram divided by the molar mass. Now what is the mass in gram given? The mass in gram, that is 36, divided by molar mass. Molar mass here, the mass of carbon. What is the mass of carbon? For that you have to check a periodic table. When you see the periodic table, you will find carbon mass is 12. So it will be 36 divided by 12. So if 36 is divided by 12, what we will get? We will get 3 moles. So the first formula to get the moles from the mass, that is moles equal mass in gram divided by molar mass. The mass in gram in the question is given 36, and the molar mass means the atomic mass if a substance is atom, and it can be a molecular mass if a substance is molecule. So mass in gram is 36, and molar mass for carbon, when you see the periodic table, check the periodic table, it is 12. So 36 divided by 12, what we will get? We will get 3 moles. Is it clear, the first example? I'll give more examples related to this. So we are using the first formula, and according to the first formula, moles equal the mass in gram divided by molar mass. The term molar mass means it can be atomic or molecular mass, depends on the substance. Another example, find moles of water, which is H2O, in 72 grams of water. So we have to find the moles of water in 72 grams of water. So again, first what we do, we'll write the formula moles equal mass in gram divided by the molar mass. So we have the mass in gram. How much mass in gram is there for water? That's 72. But what about the molar mass? So how to get the molar mass or the molecule? Because if substance is a molecule, molar mass means molecular mass. If substance is atom, then molar mass means atomic mass. So we have to find the molar mass of water. So for that we will use a periodic table. So how to find the mass of water, H2O? What is the mass of hydrogen? As you can see, the masses are written at the bottom. So mass of hydrogen is 1. So mass of hydrogen is 1. And how many hydrogen are there? 2. Plus, what is the mass of oxygen? 16. So that will be 16. So 1 multiplied by 2, that's 2 plus 16. So the total mass, the molar mass of the water will be 18. So the molar mass of water, that is 1 into 2 plus 16. And when we solve this, it will be 72 divided by 18. And 72 divided by 18, what we get? We will get 4 moles of water. So actually, in 72 grams, how many moles of water are present? It contained 4 moles of water. Is it clear, this example? To everyone? That's the first formula of the finding moles, that moles equal mass in gram divided by the molar mass. So according to question, we have 72 grams of water and the molar mass of the water. To get the molar mass, we have to use a periodic table. There are 2 hydrogen atoms, each is having a mass of 1, and there's only 1 oxygen atom which is having a mass of 16. So total mass of a water is 18. So 72 divided by 18, the total, the result will be 4 moles of H2O. Another example, and we are using the first formula of the moles because there are 3 formulas, but the first one, moles equal the mass in gram if the mass is given divided by the molar mass. Find moles of calcium carbonate in 25 grams. So we have the formula moles equal mass in gram divided by the molar mass. So mass in gram is 25. But what about the molar mass? So for molar mass of calcium carbonate, we have to check the periodic table. So we have a compound which is called calcium carbonate, CaCO3. Calcium, what is the mass of calcium? This is a key written, so at the bottom the masses are given. So what is the mass of calcium? It is 40. So mass of calcium is 40. Plus, what is the mass of carbon? 12. Plus, what is the mass of oxygen? 16. And that is multiplied by 3. Why multiplied by 3? Because there are 3 oxygen atoms. So when we write calcium is 40 plus carbon is 12 plus oxygen is 16 multiplied by 3. So this will be 25 divided 40 plus 12 is 52 and 16 multiplied by 3 is 48. So 52 plus 48, the total sum will be 100. So 25 divided by 100, how many moles we will get? We will get 0.25 moles of CaCO3. Is it clear, this example? So the first formula to get the moles, that is mass in gram divided by the molar mass. Mass in gram is given and molar mass is not given, but you have to use a periodic table. You can work out the molar mass, and mass divided by molar mass, you will get the moles. Now what is the second formula? The moles is equals to concentration of the solution, concentration or amount of solution multiplied by volume of solution in dm cube, like all the volumes in decimeter cube. That's a formula. The second formula, moles equal concentration of a solution multiplied by volume of solution in dm cube. So if I say find moles of HCl with concentration 2 mole per dm cube and volume 0.5 dm cube. So we have to find the moles of HCl which is having a concentration of 2 mole and the volume is 0.5. So what is the formula? The second formula to get the moles is the concentration of a solution multiplied by volume of solution. So moles equal the concentration of solution multiplied by volume. The concentration of the solution is given 2 and the volume is given 0.5. Volume is in dm cube. But example, some question they give the volume in cm cube. So you have to convert into dm cube, and from cm cube to dm cube you have to divide by 1000. But in this question it is already in dm cube, so we don't have to convert. So 2 multiplied by 0.5, that's equal to 1 mole. So this formula is used when the concentration and volume are given. And what about the first formula? As you can see, the first formula is used when the mass is given. And the second formula is used when you have the concentration and volume. You multiply, you will get the answer. The second formula is the concentration of the solution multiplied by volume of the solution. The concentration of the solution in this example is 2 and the volume of the solution is 0.5. So when 2 is multiplied by 0.5, what you get? You will get 1 mole of the substance. So the second formula of the moles, we multiply the concentration with volume. Another example. So moles equal concentration of solution. I'm writing in short concentration as CONC multiplied by volume of solution in decimeter cube. Concentration of the solution means how many particles are there. That means the concentration. It's the same concept like density. If high concentration, it means more particles are there. Low concentration means less particles, less number of particles. The concentration refers to amount of particle present in the unit volume. It is same as the concept of density. Because in density, how many particles, like if I say we have two substances of equal volume, but different number of particles. Which substance is having high density? A or B? Which substance is having high density? It is A, because more particle. And if I say which substance is having high concentration, it is A. The term concentration means how many particles present in a unit space. So it is having more particles, that's why it is high concentration. Less particles, so it means low concentration. So concentration refers to number of particles present in a unit space. And normally it is used for solutions. So find the moles of sodium hydroxide of concentration 3 mole per dm cube and volume is 250 centimeter cube. So we have to find the moles. The formula for finding moles is concentration into volume. What is the concentration given when you work out? It's given 3, like 3 particles are there in a unit space, multiplied by volume. What is the volume? 250 cm cube. But whenever we substitute the volume must be in decimeter cube. So how to convert cm cube into decimeter cube? So we have to divide by 1000. So 250 divided by 1000, that's equal to 0.25. So the volume is actually 0.25. So 3 multiplied by 0.25, that's equal to 0.75 moles. Is it clear? This example, how we can use the second equation to get the moles, or second formula to get the moles from the concentration and volume. Another example, as we know, the second formula of moles equal concentration multiplied by volume. So if the question is find the moles of NaCl of concentration 4.5 mole per dm cube and volume 100 cm cube. The second formula for moles equal concentration multiplied by volume. The concentration, we have to find moles. The concentration is 4.5. The volume is 100 cm cube, but we have to convert volume from cm cube to dm cube. So it should be divided by 1000. So 100 divided by 1000, that is equals to 0.1. So it will be 0.1. And 4.5 multiplied by 0.1, that's equal to 0.45 moles. So we'll get the 0.45 moles of NaCl. So this is the formula if the concentration and the volume are given. The third formula for the moles that is used for gases. So moles that is only used for gas of gas is equals to volume of a gas in dm cube divided by 24. So the third formula, moles of a gas equal volume of a gas in dm cube divided by 24. Example, we have to find moles of oxygen in 48 dm cube. So the formula that moles equal volume of gas divided by 24. So what is the volume of the gas? We have to find the moles. The volume of the gas is 48 dm cube. So that is 48 and divided by 24. So if 48 is divided by 24, what we get? We'll get 2 moles of oxygen. So if volume is given, we use this formula that moles of a gas equal volume of a gas in dm cube divided by 24. And volume should be in dm cube. If volume is given in cm cube, then again what you have to do, you have to convert the volume into dm cube by dividing with 1000. Another example related to finding the moles of gas. So find moles of nitrogen, which is a gas, in 200 cm cube. So whenever we are finding the moles of a gas and the volume is given, the formula moles equal volume of gas divided by 24. But volume of gas should be in dm cube. So here that is 24 is fixed, but volume in this question is given in 200 cm cube. So we have to convert into dm cube. So we divide by 1000. So when we divide by 1000, it will be 0.2 decimeter cube. So this will be 0.2 and 0.2 divided by 24. What's the answer for 0.2 divided by 24? 0.008. So 0.008 moles will be there for this gas. So if I summarize the formulas of the moles, so finding moles by formula, there are 3 formulas which we can use to find the moles. The first one, the moles equal mass in gram divided by the molar mass. The second one, moles equal to concentration multiplied by volume. And the third one, moles equal volume of gas divided by 24. So these are the 3 formulas related to moles, and it depends on the condition. Different conditions we use different formulas. So how you recognize which formula to use? Number 1, if mass is given, then you will use this formula. The second one, if concentration and volume are given, you will use the second formula. And the third one, if volume of gas is given, that's condition, the substance should be a gas. Yeah, the last one is only used for gases. It cannot be used for solid. The substance must be a gas. So if we are finding the moles, we can use formula or we can use a ratio. If we are using a ratio, equation we will use. If we are using a formula, we don't need any equation. We just work out according to the values given in the question. So I'm writing some questions now, and I want you to recognize that which formula should be used. If first formula is used, write 1. If second formula, write 2. If the third formula, write 3. Because important thing is to recognize like which formula you should use according to the question. So first one, if I say find moles of hydrogen in 20 cm cube, which formula I should use? 1, 2 or 3? The volume of a gas is given. So the first example, find moles of hydrogen. So we have the formula moles equal volume divided by 24. But keep in mind this is only for gases. So that is, but the volume is in cm cube, so I have to convert into dm cube. So I should divide by 1000. So this will be 0.0. So this will be 0.02. 0.02 divided by 24. What's the answer? So 0.0008. Another example, find moles of zero point double zero divided by 24. Because 20 divided by 1000, so 20 divided by 1000 is 0.02. And 0.02 divided by 24 is 0.0008. The second example, find the moles of H2SO4 sulfuric acid in 40 cm cube of concentration 3 mole per dm cube. So that's the second example. Which formula I should use? 1, 2 or 3? The volume is given and the concentration is given. So if you have concentration and volume, we should use the second formula, and according to that, moles equal concentration into volume. Concentration is 3, but the volume again in cm cube, so you have to convert into dm cube, divide by 1000. So it will be 0.04. So 3 multiplied by 0.04, that's equal to 0.12. And the third example, if we want to find moles of sodium oxide in 30 grams. So we have the mass in grams, so we'll use the first formula. Moles equal mass in gram divided by the molar mass. The mass in gram is 30, but about the molar mass of sodium oxide, you have to use a periodic table. The formula for sodium oxide, mass of sodium is 23 multiplied by 2 because there are 2, and mass of oxygen is 16, and we'll add, so 23 multiplied by 2, that's 46, plus 16, so it is equals to 62. So 30 divided by 62, which is equals to 0.48. So this is how we use the formulas. In exam, you will have questions, can have parts, the question related to moles. Some of the parts can be solved by using a formula, and some of the parts can be solved by using the ratio. But most of the question is by ratio, and some parts can be solved by using a formula. Okay, in this question, as you can see on your screen, the concentration of hydrochloric acid is 0.5. How many moles are present in 25 cm cube of this solution? First thing, we should use a formula because no equation is given. And then which formula we will use, first, second, or third? So we'll use the second formula. And when we use a second formula, according to second formula, moles is concentration into volume. So concentration is 0.5 and the volume is 25. But again, I said volume should be in dm cube. So divide by 1000, 0.025. So 0.5 multiplied by 0.025, that's A will be the right answer. Is it clear, this question? As you can see in the question, they are asking the concentration of hydrochloric acid is 0.5. So concentration is given to you, which is 0.5. Unit of concentration is mole per dm cube. How many moles are there? So they're asking for moles present in 25 cm cube of the solution. So volume is given, that is 25 cm cube. So the formula which relate concentration and volume, moles equal concentration multiplied by volume. The concentration is 0.5 and the volume is 25, but that's in cm cube. You have to convert into dm cube, so divide by 1000, so 25 divided by 1000, that's 0.025. So that's 0.025. So when you multiply these two numbers, 0.5 multiplied by 0.025, so your final answer will be 0.0125. So it matches with which option? It matches with A. Is it clear, this example? Yes, you have to know that all the volumes should be in dm cube. So you have to know if the volume is in cm cube, to convert into dm cube, you have to divide by 1000. It's a unit conversion that the volume, whenever a volume is given in cm cube, all the volumes must be in decimeter cube. And to convert the centimeter cube into decimeter cube, you have to divide by 1000. So these are the three formulas of the moles. Moles equal mass in gram divided by molar mass. Moles equal concentration into volume, and moles equal volume of a gas divided by 24. So first, second, and the third formula. Anyone having a doubt related to the topic today? So today we discuss how to find the moles by using a ratio or a formula. In the next session, we'll do questions from different past papers related to this mole topic. So we are done with topic 4 as well. There are some extra topic in moles that we will do later after completing most of the examples of moles. But the overall topic 4 is completed, which is about the moles empirical formula, molecular formula, and writing the chemical equation. So I'll share another link and discuss the past paper.